right. Hi, everyone. My name is Tim. I'm trying to get used to speak and sit, but I guess it's the best place here to do that. So that's me. That's my background. Today I will be teaching you a lecture session or whatever you want to call it. I will be sharing some knowledge on the best practices for smart contract development. Basically, the title would be to secure development best practices for Solidity. So briefly about me, to introduce myself. So that's me in my natural environment, drinking some tea and recording bird chirping in forests in Canary Islands. This is what I do in my free time. Feel free to connect with me on X or email me. My background is electronics engineering. I've done in the past a lot of systems design and electronics, and used to use like a lot of control theory and that kind of stuff. Did digital signal processing, electromagnetic simulations, and around 2020 I jumped into the blockchain vibe, and I started with a company called Moonstream.to. We did a lot of initially analytics, so understanding how the blockchain works, and did some product development. And in Moonstream, actually, I faced first security challenges of the blockchain space, and I'll touch that brief later. And that kind of led me to the work in Open Zeppelin, which gave me the biggest security background in Web3 space in my career so far. I worked there a lot with understanding the DAO security models and architecture, contributed to the Ethereum Enterprise Alliance specifications, did a bunch of solutions and stuff. And now I'm founding the Pyramid Lab.
Sorry.
Yeah. Ah, okay.
Sorry.
Yeah, I can do that. Yeah, now I'm funding the Pyramid Lab. It's more like, it's not a security-oriented company. It's more like for communities and DAO tooling. However, it involves a lot of my background, and I incorporate experience from the past work there in different ERCs and other stuff. And this is why actually you might not see me often here in Invisible Garden, because I'm invisible in my Airbnb arranging all of this stuff, which takes like to found a new company, basically. I'm also learning Chinese language, so if someone wants to have a language exchange, I'd be happy to do that. I speak 3 languages. Besides English, I speak Latin and Russian, so you know I can offer some for exchange. Okay, so the plan for today is. Oh, by the way, you know, I'll share the link for these slides to our Discord, just so that
learn and share.
All right. Just so you can follow along, and there will be some links you might want to click and find it easier to click, not to scan the QR codes. All right. So yeah, this is our plan. We'll go through you know, introduction, planning, coding, testing, auditing, deploying, operating. And what we'll be doing today, I'll just walk you through the best practices. I'll overview some briefly examples, and I'll share some references to the tooling and sources where you can further learn. I will not dwell much into the practical examples, but we will have another session with me, I think Friday, where I think we'll get like much more into like down to the code. All right, so yeah, so why do we like, what's our goals? You know, write safer, spend less time on fixes, and actually, if you work on a serious project which goes to the audit later on, you reduce your costs of auditing because it's expensive. Yeah. So like I know, guys, you had a lot of mathematics and like crazy lectures before, so I tried to make it a little bit more entertaining, because it's not like crazy stuff here happening. So we'll have some memes around and just to relax brain a little bit. So why do we bother? In 2023, it's like almost $2 billion were hacked from the Web3 space. And not just like saving the audit costs, it just can save you the buck and your users. And this is very important also to bring the adoption to the blockchain. The users should feel that their money is not gone. So the Web3 specifics, though, they are. By the way, is here anyone who has a past experience in security in IT? Raise your hands. Right, one. Okay, 1.5, 2. All right, so like, the things are not new in the Web2 space. The security always been an issue, but Web3 specifics brings this problem that anyone can read your deployed code, and when hack happens, anyone can see it happening and can just reproduce the transactions. This is why the hacks on like Web3 actually are so loud. It's not because they are so loud, it's just because they are much more visible than Web2 hacks, when no enterprise is gonna tell you about that they got hacked, unless it's like already publicly known to everyone. So they're gonna try to hide it. You cannot really do this in Web3. Yeah, migrations are hard. You're reliant on private key infrastructure, which becomes super important and much more closer to the users who might be not tech savvy to it. Less law enforcement. Well, it used to be. Now, like anyways, like Chainalysis is doing a great job, and others. It's not a smart thing today to do a crime on really blockchain. I'll get to that later, how you can actually use this for security in your process of developing. And then we have a novel attack vectors, MEV, transaction sniping, DeFi exploits. It's something hasn't been before and wasn't that obvious for many of us when we first deploy our contracts. The problems will happen from unseen vectors, basically. So where do we start? When we do start with like good project, when we want to have everything from the day 0 shift to the left, all of the security concerns, we want to have a specs. Having like engineering background with hardware development, their engineers will just simply refuse work if you don't give them the spec. And if they will not like the spec, they will just not do a thing. In software, it's much more dynamic, and project managers always say like, we'll figure out it, So it's okay, but the more you can shift it to the left, the better opportunities it gives to you. And it must be clear, it must be readable, and it must be readable by anyone in the industry. It's going to be not just your source of guidance, it also will be the source of people writing documentation, blog articles, everything on your project. So, don't be this guy who has to, don't make others to be this guy to figure out your specs, and use some RFCs which are widely adapted to have some meaningful wording in your specs. And now let's see some good example of decent technical specification I saw in the documentation. So it avoids initially to loading you with a with a wall of text, and instead it's a great idea to fit the thing in. Yeah, by the way, it's just like software things which I'm sure generally most of you know, but I'm just recapping here that basically like good spec has diagram to see like in one sheet of paper quickly, okay, what's the processes. And it's going to be super useful if you have it for an auditors, for anyone later, and even for yourself later when you forget how the complex system works, you just quickly check the diagram. Okay. And this is one of the good examples. Really, I loved it. I worked with internally in OpenZeppelin with Arbitrum RC20 Bridge, and reading their docs were like, that's nice. I can immediately understand what the contracts are doing and what are the names of the contracts, where the control, like here is the money flow, where the flow goes, you know. So that's certainly a good one, and you can take the links. I'll share the QR codes along, or press this URL if you're open slide link and following along. And then let's take some bad example. I also worked with Polygon POS bridge, and I was looking yesterday eve like their specs. I wanted to find a diagram. So basically, you go to the POS docs for the bridge, and you like click the link, and you end up like with this. And it's already not in a bridge architecture; it's overall architecture overview, and it's like, okay, like doesn't help me really much, you know. I cannot like, yeah, I know you have a Heimdall between, but you know, what's up, you know, with that. So you know, try to when you design a diagram, try to elaborate as much connections. Either do the flow control or information flow, or in DeFi, I guess, finance flow definitions there. Yeah, so let's go on from there. And another important thing when you're designing the technical specs is basically to model your threats and clearly understand, where from the arrow is going to fly. There is a lot of things to do. It's literally, actually, many will argue that it's impossible to actually model all of the threats immediately because we don't know some of the threats. But there are ways, to just break this into pieces. Start by wearing hacker hat. This is ongoing discussions, by the way, on 7702, where I was like wearing the hacker hat and trying to figure out, okay, how, like if they make it, if they make the CIP happen, can I break something? And it's not just, I'm not just shilling here for myself, by the way, but just generally, like if you have any question, like which is, you think is large Ethereum community could comment on, please do the Ethereum request for comments. It's ERCs literally stand for requesting you to comment my code or my solution. And like EIPs are basically the same in that regard. So, go to the forums, look for there. It's actually like you're almost getting a free audit if you're going like and trying to make an ERC, right? So it's just like it's a great thing and you're getting for free. You just need to spend some time and learn how to like make the proper pull request and maybe attend to the call with the IP editors so they can like help you out quickly to get through the first friction. And try to identify, like, in your application, try to identify, like, what are the vulnerable patterns, what I'm doing which could lead to the problems. And I'll get later to this, like, slide, but this is a real literal, like, very interesting attack that happened last year by combining trusted forwarder contract for meta transactions and doing the multi-call sync contract. And this is something that could be seen if it would be really analyzed by like authentication, authorization, kind of like break it into the pieces, and look around the contracts you're building basically. And it really helps the auditors as well if you define the invariant for your system. So if you give the assertions, here's a simple one, like, if you're using your C721 bridge, this token should circulate either on layer 1 or on layer 2. It shouldn't exist freely circulating on both of them. That clearly breaks your system invariant requirement. And if you have these definitions, by the time you're going for an audit, it's so much easier for the auditors, for anyone who's implementing security monitoring for your application, to actually, understand what they're dealing with. Yeah, assess integration risks is something that I'll cover maybe perhaps more in the next lesson, but it's web is a web. You want to connect, you want to integrate other projects. This is what gives you power to actually, you're leveraging the industry, but it brings the risks, and you're using like oracles or DL protocols or meta transactions, any on-chain infrastructure. It's a risk, and assess it clearly. Try to write do the diagrams again. Draw where your protection layers against threats are there, and document them. Document the potential threats. For the Web3, particularly for Ethereum, you can use Immunify severity classification system. It really helps out as well for in audits later on. The stride analysis is something from it's just generally IT security thing, and if you just look on the Google for a stride, you'll find a lot of methodology on the threat modeling. Yeah, getting to the code clarity and coding a little bit. So it's not like everybody's here, I guess, are developers, so everybody understands how hard it is to read unclear code. So I'm not going to stop here really for a long time. Just try to make it clear. Follow the principle of less knowledge. Use the battle-tested libraries. That's pretty much it. And then divide the code clarity. One of the things in Solidity, really use the abstract classes. Use the libraries. Use the libraries whenever you have a functionality for internal reusable things and upgradable or proxy memory management. And then in abstract contracts, you can specify your environment requirements, you can specify your functional requirements. And also, when you're building the project, this means that you can break the tasks and write specific tasks for functional requirements, environment requirements, without thinking how the ownership of that function is going to look like, how is users going to be authenticating and authorizing access to that function. Implement the functional piece first. And then you can wrap it here, so we have abstract contract, distributor, and then it's implemented. And the implementation, it adds this modifier that only owner can access it. And this is a clear separation. So when you're looking on abstract, you can easily reuse it. You can build another implementation, maybe you're a DAO or you're a multi-sig, or you want you might have so many different approaches there, really. Yeah, validate the inputs as well, and try to see on each stage what the inputs for your functions can take, and assume that any function in the contract can be called in any order. That's something that happens. People have an assumption that, yeah, they will be doing this, and then someone comes and just do it in reverse order, and boom, you have a problem. Yeah, and then document things. So write explicit and thorough documentation in an AdSpec format. These are two tools you can use. This is OpenZeppelin managed. This is I wrote myself for if you're using MK Docs for generating documentation. These tools can help you to take this AdSpec and get from there documentation you can put your own Docs portal for API. So when you're doing this, you're basically creating a documentation portal already for your users and for your developers. And from there, let's go to the defensive programming. So this is actually what everybody is caring about, I guess, here. And how do we actually write things safe? And there is so many that I'm not able to cover everything, but try to define clear your code. Read some materials. This is example of how expectations can go wrong, really, and we'll touch that later on in the next lesson. But I can just drop that here. It's a cross-contract reintrusive attack, which basically relies on someone expecting that called contract will behave in some expected manner. Whenever you're doing external calls, delegate calls, or even a value transfer like ETH sending to someone, do not expect they behave. Expect they can misbehave and they can have a fallback functions on the contracts that contain code to attack you. One of the great resources I really can recommend you learning and using in your practice is Ethereum Enterprise Alliance specs. Don't really look much on the enterprise word here. It's just a great material and resource where industry-leading specialists gathered together and they worked out very thorough and very detailed specifications and requirements for things like DeFi protocols, general trust assumptions in a crypto, how you should work, how you should write the code, and what things you should avoid doing, and if you do them, what should be done if you did it. So, say if you're doing the delegate call, follow their best recommendation. This will save you a lot of time later on, and it will also, just give you a lot of education about how you can get it safer for your app. Yeah. By the way, if anyone wants to interrupt me and ask some question, feel free to go and do that. So once you kind of already have some code base and you kind of already think that I don't really see any problems there, but likely they are. It's a really good idea to use static analyzers. And here are a few links. This is an interface for my personal project in OpenZeppelin Defender. And it's super useful, it just immediately throws all of the findings, the whole audit company incorporated in the automatic scanner, and you can use it as a source of your improvements, and usually it's gonna be a lot. Some of these will be really missing and not relevant to your code base, but it's good just to go through and see what the static analyzers think about your code. Functional testing, obviously, write the tests. The more tests you write, the more are the chances that you're going to notice some problem. Test the libraries and abstract functionality separate, though it's a good idea. In a small project, you not always have resources to do that. Sometimes you'll just write one big piece.
Yeah, just a quick question in that regard. I think when you write software, when you start writing the tests, do you write them while you write your script, or do you do that everything at the end? Do you do more test-oriented programming, or would be just curious?
Usually, if I write my contracts, what I would do, I would create my technical specs, and in the technical specs, I already at that moment I'll start writing down this jest style, it can be transferred only by the owner. It can be done, and I'll separate those in the functional and the security requirements. And I'll write them down as a text before I actually write any code. And this is this whole thing of shifting to the left. So you're trying to do as much of work as possible before even writing one letter in Solidity code. But the moment I'm starting writing, I'm starting writing the tests really at the moment when I already understand, okay, I wrote quite a big piece of functionality, and I just, okay, does this thing even work really right now? So at this moment, I'm bringing up this paper I have with all of these functional security requirements, and I'm like, okay, let's try implementing these tests and see if it works. And if it works, I'm going just to keep on developing until I get the full picture of my commit or piece I basically see as an independent work I can merge into my repo. And then I'll add the tests and I'll complete them. And also at least in my practice, I do the deployment tests. So whenever I write the, actually most of my tests I write together with the deployment. So I'm assuming the deployment fixture is part of my infrastructure. But you can also separate that, I just invite you at the end, still do the deployment tests to verify that your scripts will work fine. And if you have any migration script and any operational script, test them thoroughly as well. So even if you didn't expect, the script to be used, maybe that's like something you did like for boundary case to handle some situation during your operations, but test it still, please. So actually returning back to that meta-transaction multi-call attack which happened, in my personal opinion, the reason why this vulnerability got actually to the production was that people often don't think that, like, in this regards of that you have the layered approach, which is traditional security, IT security, that you just cover all of the holes you can, and there is visibility there is clear separation from each security and functional layer. So if you would think on this matter of okay, who is authenticated and what this authenticated person is authorized to perform, these are two different topics, but I was surprised to see that many developers actually they're like, oh, what's the difference, it is different. You're trying to understand who is calling you, and then you're trying to understand who is this caller, what this caller is permitted to actually do. And if you think through your app while building in these matters, it will obviously help you. Change your challenge your assertions and look for known exploits. It's really helpful to follow the industry news about who's been hacked, what happened, to understand what are the news in the ecosystem generally. Another tooling I can suggest once you're already in the advanced stage of your project is to add the fuzzing. Some of the code, sometimes it's very hard for human to understand whether it will perform well under different values passed into the functions, and defining basically invariants and then running fuzzing analyzers will give you these answers. Here are a few, and there are different methods how you can, there are three types of how you can do the fuzzing. You can do it stateless, stateful, and differential. And then once you already cannot really find any problem in your code and your team thinks that it's maybe it's fine, we should go to an audit and get an audit. Try to do internal review first, really. A lot of big companies will have the internal review teams. They would even have internal full-time audit teams, but that's for very big companies. But even if you're small company, you can just ask for your peers to do a proper review of your code once more time, and try to break it as a whole piece of application which is ready to go for an audit. That will not just it will find any possible vulnerability, it will also create some notion in your team, in your collective, about how this code works. And if there is any question of how this works, you're not single person or single team who knows that. So that's valuable, and it's valuable, and once you pass this stage for really big projects, you're coming to the auditing part. And before you do that, you know, when you're approaching an audit company, yeah, like, you have to prepare in advance the scope you're going to ask them to audit for you, and adhere strictly to that, because the auditors, they have their own project management, they have their own schedule, and they have to be like really sharp as possible on the time when they are scheduled, to give the most attention they can to your project. So providing the frozen commit, no alterations, don't disturb the timeline, and then during the audit you'll have to be collaborative, answer any questions, provide details, edge cases, integrations, and then again, like if you had a good technical spec from the beginning, you won't have much of those questions. But if you didn't, that's likely then you have questions which will, they might get you to this underwater thing when you're basically realizing that your technical spec was not complete, and then you have to fix some architectural level of vulnerabilities, which is basically like, maybe I should just quit my job and stop doing this project. So this is why the technical specs is something I think is most important. Later, when you got audited, there is some things which are like out from the audit scope usually, which is like operations, like doing the deployments. And like I've seen with practice that people will use a message sender to set the owner, and it used to be actually normal practice. I think even in Open Zeppelin contracts, it used to be like a default behavior, which right now is being discouraged. The deployer should have the deployer key should have a singular purpose of doing the deployment, and then any ownership, minting, it should be sent to someone else. It shouldn't be the deployer. Your developer machine or your GitHub integration, which does deployment, should be like specific to the target, really. Yeah, and then getting back to my experience in the Moonstream. So testnets and devnets are somewhere where you're building your app, you need to have tests with your product team, you need to understand how it behaves in more or less like real environment, not just unit tests. So usually projects would either launch their own devnet or use a testnet or combine those. And how do you understand which one is really good for you or bad for you? There's no direct answer, but I can share the perspective that yes, of course, obviously, if you're using the testnet, you can have a much closer financial activity simulation than you would be getting through the devnet. But there is one drawback, and I've seen that in my practice, is that if you're assuming that no one is watching testnet for the vulnerabilities, you're wrong. They will be watching and there's so many ways you can actually understand, what is a project, which project actually is building, especially if your code base is public. So they can see how your contracts interact, how they behave. They can fork the public testnet, and they can start experimenting the attack vectors, which happen right on the deployment moment. They can front run the deployments, and you just have to be aware of that fact that we witnessed that we're doing the deployment and we're seeing someone just interacting with the contracts just the same block. It was on an MEV, they were searching for these transactions, and okay, nice, good job, you just got an NFT, but anyway, it was just on the hype of the NFT price, so it was quite painful actually. There are some standards in that regard as well by Ethereum Enterprise Alliance. My personal advice here would be to start with a DevNet. So for my personal projects, we're running, I'm just hosting my own developer network. And from there, we're going to move the testnet to see, but the testnet basically, it means that you're already like, you kind of could deploy it just to production, but you give it just yet another chance to see how it will behave on the economic system activity level. But then if you have a very private project, which you want to deploy from a private repositories, or even don't want to verify the bytecode in Etherscan, don't use the testnets at all. Set up your closed VPN developer network and don't let anyone in even for their PC endpoints to scan that. If you have any questions how you can do that, like I can help you out, you can always reach out as well. Yeah, the upgradability, right? When I first heard about Ethereum, I had a feeling that the value offering of Ethereum is that the bytecode is low and it's immutable. Raise your hands who had the same expectation. And, yeah, so like at least half of the group as well around. So we really cannot avoid doing the upgradability today because we are developing, we're learning, attack vectors might change, standards might change, and we want to adapt, we want to keep that for our users to have a great experience. But really, already on the level of your technical requirements, you can see if you do need the upgrades and where. Which pieces of your infrastructure can be immutable? Do them immutable. There are some also possible storage collisions which might happen if you're using upgradable storage, upgradable contract, proxy contract storage layouts. So you have to watch out for that. Usually the auditors, if you're going for the audit, they will thoroughly check for that as well, actually. Yeah, the initialization is important. As I mentioned, someone might try to front run your initializers. Just have to be aware of that. And if you end up doing the upgradability, make sure that the upgrader role is someone very secure, the DAO or multisig. And if you have, like, say, upgradable token, the exchanges, centralized exchanges, they will actually not like a lot the upgradability. So you'll have a more hard time listing your token, say, on CAX. So really consider if you really need to do that, and if you need to do that, if you have absolutely must, then do it proper way. I won't mention here much, but I actually am working on a project which is kind of trying to create new paradigm for upgrades, but that's too early really to teach about that. Anyway. Congrats. So I have quite a quick run through the development practices and how you do the audits and how you do the deployments, and now we're finally deployed our contracts. We opened the champagne, and not really. We have the marathon now. It's still the security matters. If you have upgradability, it means you have some private key infrastructure. So your team should be just, it should have basic IT security knowledge. Also, people in your team should, God bless you, should be able to, handle basic Web3 operations is important. So if you have a multisig signer who doesn't know how to use, multisig, that's a risk in its own. So with that comes that actually, for the big projects, it's always recommended to have a thorough incident response plan, just for the case if things go wrong. And from your threat model, this is where you're going to use the threat model you designed on the very left stage of the project. There you can, clearly okay, here's our threats. We know that these things can go wrong. This is what we'll do if they go wrong. You know, have a plan, have a people who are in charge for executing pieces of that plan. Make sure that they are capable. Make the drills, try it out. Try it on testnet, like impersonate something. You can launch your private DevNet, impersonate accounts, and simulate the incident response, and see how your team performs and actually handles that. There are things, like just a disclaimer, that is impossible to fix. Let's say there is a vulnerability like the one, like the spoofing attack I mentioned earlier. It was just like white hat rescue, the only option. You just have to just go and create a white hat rescue contract. And if this happens, the really right thing you have to be aware of is that if your vulnerability is widespread, so it's like not just your contracts are being affected by, let's say, because like, let's get back to this one. Where was it? Yeah, so this was actually in the third web libraries. So there was a lot of projects involved. And they all were vulnerable to very, very, like, basically sender could execute the transactions from like where the message that's like the authentication part was seeing that it's a contract itself calling. So it could do anything there. And if that happens as widespread vulnerability, what you should do is actually you should try to find some security firm, some ecosystem player who is kind of sitting above the vulnerability everyone got, approach them privately and expose it in that way that you're responsible for other projects. Because the moment you're doing the white hat rescue from your project and you're like, yeah, I'm safe. Like, you know, the people are scanning the chain, they're seeing the vulnerability, they're like, okay, he saved his funds, but there's like 1,000 more projects who are vulnerable, you know, I'm gonna hack them now. So it should be coordinated ecosystem effort. And if you do this just for yourself, yes, in the short term, maybe you get win, like, and you might even like do something like temptation, like, you know, to do the Twitter post about that, like, see, like, we disclosed the vulnerability, we found it, we're good guys. But really, in the long run, you're creating the problem for the ecosystem, you're dropping the adoption rates, and you'll have less users because just industry will be not perceived as secure. So this is very, I'd say, the most important topic, getting back to the incident response when they happen, and especially in the discovery of new vulnerabilities in 0 days in your contracts. Yeah, make sure that people are reachable as well. And I forgot to add here on the slides, but there is a security alliance for blockchain, and there is a SEAL group on Telegram where the top security firms and auditors and researchers, they all are there, and you can just drop the message in that group. You can just reach out there. If you see the vulnerability, you can go to the Telegram channel. Yeah, I'll add the link to these slides just a bit later, and you can open the slides from Discord and get it. So if anything goes wrong, you can contact them. If it's a widespread vulnerability, they will assess it and they will handle it from there. Yeah, and then the monitoring. So, you know, you have to be aware what happens to your project. The invariant states you defined very early on, monitor for them. Maybe they suddenly change. And if they change suddenly, it means that something went wrong, maybe. Then there are some things like, you know, price oracles. Here in the screenshot, we can see that there is like, there is a rejection on the price feed from, like, price feed got rejected on a compound v2 protocol. And that's actually a big problem, because when the market changes so quickly that the candle just goes down, the contracts, the oracles have no time to adapt for that. And if you're building a DeFi protocol, that's a big security. It's a risk which is inherent in the system architecture. It's quite, at least it used to be very hard to deal with. Now they're using, on the V3 markets, they use a chain link, and it's much more stable. But then there is, like, let's say also, like, see, this is like, if you cannot read, I can read for you. So it's like the address has been delegated enough of comp tokens to pass minimum threshold for governance event proposal, which means that there is possible a quorum attack on your protocol happens. And seeing this early on, it allows, you know, the community to start reactively discussing, okay, react to that, and if the proposals go on from this address, it will draw more. It should draw more attention. And what I can recommend from secure developing perspective is that in order to build a robust monitoring infrastructure, you should have deployment artifacts and their dependencies visible in the repo. So usually, if you're using hardhat deploy, you would have like deployments directory created for you. You know, please commit it to your repository. So if some third party needs to build an integration for building monitoring for you, that's easy. They can just go to your deployments directory, grab the ABIs, grab the contract addresses. But then if you're also using some infrastructure which is critically important for you, it's also good to design some system or list those contracts so that they are also visible, and monitoring can be implemented if that vendor infrastructure is part of the invariant assertions. All right. Actually, it's quite it. It's a quick rundown. Yeah.
Yeah, I think you're talking very intensely about like all the kind of like security measures that you can take when actually deploying the application. I mean, like obviously, like audits in general are like a very big hurdle for loan projects. It's very expensive, it takes a lot of time, and generally, like if we compare building products to Web 2, where you continuously launch something new, and I think it's definitely makes it even bigger hurdle in Web 3. So do we even need audits if we, right? I mean, I think you're talking about DeFi, but there are also other areas. So do we need audits, and could AI audits be an actual alternative to, yeah, to the audits you're talking about?
I'll start from the later. So the AI audits, let's say here. So these are just GitHub repos. This is static analyzers. But these tools, this is why they don't post them like in open source, because there are some models. And you can do the abstract syntax, EST, to analyze like and find reentrances and that kind of problems. So you not necessarily need an audit in that regard. That yes, we do have an AI tooling, but there is a but that the AI is just built on the models, which someone has to put them inside. And when you do the audit is where they find this model data sets. So if you write something novel, which is new, it won't really help you much. Then regarding do we even need an audit, it's if you're a really hardcore developer, if you really know your code base, if you know that your apps are super safe, if you don't use a lot of, I'd say if you don't use a lot of like external contracts which are calling as well, if you really understand the memory layout of your contract, then no, you don't need it really. And then if also if you don't have like large investors who require you to do an audit as well, because like if you're just like doing this for fun and there's no much value locked, yes, of course, obviously you can just deploy it and see how it goes, and then if someone goes wrong, you just redeploy it and battle test it. Yeah, so if you have any like question, yeah.
I think I have 2 questions or 3 questions. You talked about technical specifications, right? And in your experience, are these methods like traditional software engineering technical spec sheet, like with diagrams, with use cases, true false, inverse false, with expectations? And the other question is like, if you find a good project that's already audited, do you recommend, and you don't find the technical specifications to work on top of this project, do you recommend to do these tech specs as well, or just start to write specs for new features on top of the project?
I'll start with the latter again. So if you find a project which is decent, it's audited, it's well documented, my approach would be like, okay, I have my technical specifications, I see that I need a module, and then I'm writing down in my architecture that I select a vendor, and this is my vendor. And this vendor, okay, and then I have an assertion, and I'm writing down, okay, he is an audited, we trust that that his specifications, his documentation will perform as it's specified. And in the threat model, you just have to review that thoroughly once more time, like, okay, what are the threat model of that vendor? What are the threats they face? Can this protocol be cause of denial of service? Can this protocol be taken over by changing the multi-sig ownership? And just incorporate this into your design, and from there, for instance, for a lot of projects, you would monitor for them. Let's say Compound DAO, they list a lot of tokens. A lot of these tokens are upgradable. And this is a security concern for a DeFi protocol. What's being done is that they monitor for upgrade events. So if the upgrade events happen on the token, like there is a security console, it's going to be notified. Yeah, and that's part of the threat model. It's not perfect. Like, I mean, you might have better solutions, but right now the industry is there. And what was your first question? Sorry.
Technical specs are managed like traditional software engineering with diagrams, with spec sheet, with this documentation.
Yeah. So do they work for Web3?
Yes. Do they usually use this in Web3 as well?
Yeah. In my experience, yes. Like I've seen like big projects coming to us, and for instance, like I really like Arbitrum because they have like a lot of assertions put on their even a docs portal. So it's already extrapolated out from the white paper and any like more academic research into like particular engineering specifications. So this certainly works. My personal and other experience with tech specs is just like if the project is not like super big and super like actually if it doesn't come like from even academia, I would say usually the tech specs quality is much lower, and you cannot pretty much do anything about that. Yeah, like you just do your best in like creating them. Yeah. So if anyone has like, during your work later on in careers, have any problems and needs to have an advice on any of those topics, please feel to reach me out. And next time we'll have interoperable contracts, opportunities and caveats, where we'll see about like, how do you define your own ecosystem, review some of the attack vectors when you're using like interoperability and ability to like reuse others' code extensively on chain. Yeah, and we'll see some operational challenges of that. So thank you. Yeah.
It would also be cool if we, I don't know, what you say next time we have another session here?
Friday.
It'd be cool if like we can look at some specific code. For example, it would also be nice to look at some code that has, you know,
yeah, we'll do that. We'll do that. Yeah, that's a plan. Because for this lesson here, I just wanted to give like brief, not even an intro. It's actually the materials, the links. This is important. Like if you read the Ethereum Enterprise Alliance specs, it's huge and it's so thorough, and it will help you a lot. So for me, it was important here to share those links because code is very specific, but the tooling you have, and if you're just starting your Solidity journey, the tooling is what you need to understand. I didn't mention here the tooling like for development of Solidity, like Hardhat or Foundry. I assume you already had some bootcamp lessons on that, and you have it. All right.
Cool.
Yeah, thank you for listening.